the measurement problem of quantum mechanics. The rules say when a system is observed, when it is measured, its state, its wave function, changes dramatically, suddenly, and unpredictably.
Now, let me ask you this. How do we know this based on if you're measuring it and it changes? How do we know? Because we didn't measure it before. Like, what observations are we making?
When we sleep, it can be difficult to distinguish between what is real and what is a dream. But how do scientists figure out what is actually real? They consider something to be real if its properties are determined prior to being measured. For example, an apple can be green, even if nobody is looking at it. However, the rules are different in the quantum world because in the quantum world, reality is created by the observer's consciousness. Recently, famous physicist Michio Kaku has proved that our universe is not locally real and nothing exists.
Do you ever put much thought into simulation theory?
Take a look at the molecules in this room. How many molecules are there? About maybe 10 to the 26th power. And to model that many atoms with a digital computer would be impossible. So, in other words, the smallest object that can model this room is the room itself. Now, once you go to quantum computers, it gets worse. Because the quantum computer computes in parallel universes, not just one universe. And so a quantum computer could model some of the atoms in this room, but not all of them. Now that means a perfect representation of reality is impossible. But an approximate simulation may be possible.
Everything exists only because of our consciousness. This leads to the question, if our world isn't real, then what is it? Let's imagine two people named Anna and Luke, who are located on opposite sides of our solar system. Two coins are sent from the center of the solar system, with each coin aimed at one of the observers. As the coins travel through space, they spin. According to quantum mechanics, it's impossible to predict which side the coin will land on. The results are completely random. But here's the interesting part. When Anna measures her coin and finds it showing heads, she instantly knows that Luke's coin must have landed on tails. The odds of correctly predicting this, even 200 times in a row, are 1 in 10 to the 60th power, which is more than all the atoms in the solar system. Despite being separated by vast distances, Anna seems to be able to predict Luke's results based on her own measurements, as if the coins had some sort of mysterious connection. This thought experiment is known as the Einstein-Podolsky-Rosen paradox. It appears to be impossible, and yet it's how the universe works. This raises questions about how something can travel faster than light and what makes up the fundamental components of our reality. How does the universe transition from a predictable state to a random one? In the realm of quantum mechanics, scientists initially believed that the world was deterministic. They thought that by knowing certain properties of a physical system, they could determine everything about it in the past and the future. However, they discovered a phenomenon called quantum entanglement, which describes a state where two particles remain connected regardless of the distance between them. This may not sound particularly exciting, but consider that this connection remains intact, even if the entangled particles are on opposite sides of the universe. This seems strange because, in the world of quantum mechanics, we generally accept that nothing can travel faster than light, which sets a limit on how quickly signals can travel. However, if you create a pair of connected particles and send them in different directions, moving them farther apart, then when you measure one particle's quantum state, you immediately know the state of the other particle. Think of it like two boxes, each containing either a white or black stone. When someone opens one box, they instantly know the color of the stone in the other box. This has been proven over long distances, even hundreds of kilometers, with measurements happening in less than 100 nanoseconds. To give you some perspective, 1 nanosecond is equal to 1/1000th of a second. So if the entangled particles are somehow communicating, they are doing it thousands of times faster than light. But there's more. Just like we use scales to measure weight, scientists measure particles to determine their properties. But what if these properties only become fixed when they are measured? This would mean that our universe can't be both local and real. At least one, if not both, of these assumptions must be incorrect. Understanding what is real can be quite tricky. Sometimes we can't see really tiny things even though they exist. We can't touch air, but we know it's there. So what does it mean for something to be real? In physics, being real means that objects always have specific properties, whether or not we measure them. It's like a tree falling in a forest making a sound. even if nobody hears it. Another part of reality is that objects can only be influenced by their surroundings, and nothing can travel faster than light. The idea of a real world is important because it allows physicists to make predictions. Isaac Newton, a famous physicist, believed that if we know where everything is, how fast it's moving, and what forces are acting on it, we can predict what will happen in the future. But when it comes to the quantum world, things become uncertain. It can be unpredictable or even random. For example, let's say we have some radioactive atoms in a container. We can predict how many atoms will decay as a result of explosion, but we can never be sure which ones will survive. Similarly, if we shoot particles through a double slit, we can expect to see an interference pattern, but we can't know exactly where each particle will land, even if we shoot them one by one. Some aspects of quantum physics seem random, but maybe we just don't have enough information. Albert Einstein had a different view. He didn't think that entanglement went against local realism. Instead, he believed that quantum physics was incomplete. He thought that there were hidden factors connecting entangled particles, and eventually, we would discover them. However, scientists like John Clauser, Alan Aspect, and Anton Zeilinger, who won a Nobel Prize, showed that these hidden factors don't exist. They concluded that an entangled particle doesn't have any properties until we measure it. So, we can't know or predict those properties in any way. If the universe isn't real, then what are we actually experiencing? A group of physicists in Los Angeles came up with a new theory based on patterns, kind of like crystals. Crystals can have different shapes and sizes. They found that projecting a higher dimensional crystal onto a lower dimension creates what they call a quasi-crystal. They took an 8D crystal and projected it onto 4D at a specific angle. From that, they derived a 3D quasi-crystal, which they believe is the basic structure of everything. The smallest building block of this 3D quasi-crystal is called a tetrahedron, which is a three-dimensional triangle with equal sides. The size of these sides is the tiniest unit of length, called the Planck length. It's incredibly small, like 10 to the power of minus 20 times the size of a proton. To give you an idea, if an atom was the size of the Earth, the Planck length would be about the size of a proton. Now here's where it gets interesting. According to this theory, similar to how digital displays are made up of pixels, the tetrahedron acts like a 3D pixel of our reality. Each tetrahedron can only exist in a few states, and the state of one tetrahedron determines the state of all the other tetrahedrons in the whole universe. But if a tetrahedron can only be in one specific state at any given time, who or what decides its state? Physicists around the world think that reality is made up of information. But what exactly is information? It's the meaning expressed through symbols. Meaning is the ability to compare or understand something in relation to something else. So, the existence of comparison and meaning suggests the presence of choice and consciousness. Just like when we measure the properties of a connected particle, meaning or information only exists when we observe or measure it. If this is true, reality could be a result of our consciousness. However, there is another idea called the simulation hypothesis. It suggests that we might live in a simulated reality with an equal chance of it being true or false. If we could somehow prove that we are in a simulation, how would we go about it? First, we need to consider that the computer creating the simulation does not have unlimited computing power. If it did, we wouldn't be able to tell if our reality is real or virtual. Scientists are looking for ways to make a simulation reveal itself through experiments that would overwhelm a computer with limited resources. At the same time, other researchers are searching for different proofs. All computer hardware leaves traces of its existence within the simulated reality it operates. Therefore, there should be a limit to the speed at which operations can be processed over time. In our universe, we have such a limit, the speed of light. It remains constant regardless of the observer and cannot be explained by physics. We might not know the exact nature of the computer running our simulated reality or its properties, but there is one thing we can say for certain. If it could perform one operation per second, its memory capacity for storing variables would be roughly 300,000 kilometers. Maybe the reason we have this speed limit is that otherwise, we could travel to another galaxy before this computer could program it. However, this is not the only sign that suggests we might be living in a simulation. In movies or video games, we often see things from the perspective of the characters. What we see and hear on the screen creates a seamless experience that serves no purpose for the characters themselves. It exists solely for our benefit. If we accept the simulation hypothesis as our new reality, consciousness serves a clear purpose. It becomes an integrated subjective interface comprising our five senses. There are no natural laws, philosophical ideas, or scientific theories that predict the emergence of consciousness, and its utility or evolutionary advantage is not evident. Hence, its main function seems to be providing an experience. However, since an experience without a clear purpose or evolutionary advantage is energetically costly, it must serve someone else, an observer or a player. If we ever manage to simulate conscious beings, the likelihood of us living in a simulated reality would greatly increase. Physicists at the University of Maryland have already simulated a single helium nucleus consisting of 2 protons and 2 neutrons. They believe that if they can simulate an atomic nucleus today, in 20 or 30 years, they could simulate a molecule, and in 50 years, an object the size of a few inches. If progress continues, it is conceivable that scientists could simulate the human brain within 100 years. This leads us to the question, if we are indeed in a simulation, we are not programmed to do specific things. Perhaps someone wanted to see what we would do without any instructions and observe the outcomes. Maybe the long years we experience in our reality would only be minutes to the creator of the simulation. However, granting a game character its own consciousness is currently beyond our technological capabilities. Michio Kaku, a highly respected and influential theoretical physicist, has dedicated his career to exploring the mysteries of the universe. One of the intriguing aspects he has delved into is the nature of human consciousness and its profound connection to reality. Kaku's insights provide us with a deeper understanding of the mind and its remarkable ability to shape the world we inhabit. Consciousness, in its essence, is a multifaceted and subjective experience that is open to interpretation and transformation. Kaku proposes a 3-level model to define consciousness: spatial consciousness, understanding towards others, and futuristic consciousness.
I have a new theory of consciousness based on evolution, and that is, consciousness is the number of feedback loops required to create a model of your position in space, with relationship to other organisms, and finally in relationship to time.
These levels represent the progressive stages of conscious awareness that contribute to our perception of self and our interaction with the external world. At the spatial level, consciousness allows us to have a sense of our place in the physical realm. It encompasses our ability to perceive and process sensory information, such as balance, sight, sound, and touch. These faculties provide us with an understanding of where we exist within a given environment. Human beings, through their complex neural networks, have developed intricate mechanisms to gather and interpret this spatial information, enabling them to navigate and thrive in their surroundings. Moving beyond the spatial level, consciousness extends to encompass an understanding of others and the broader world. This level of consciousness is not limited to humans, but is also present in other sentient beings, such as animals and even plants. For instance, a plant exhibits understanding towards others by responding to its environment and adjusting its leaves to capture the optimal amount of sunlight for photosynthesis. Animals, too, rely on sensory information to assess threats and make decisions that ensure their survival. This shared capacity for understanding and adaptation demonstrates the interconnectedness of conscious beings and their active participation in shaping reality. The highest level of consciousness described by Kaku involves using our sensory information to contemplate the future. This level of consciousness is closely tied to our uniquely developed prefrontal cortex, which enables advanced cognitive processes such as introspection and imagination. By integrating sensory information, memories, emotions, and electrochemical signals within the brain, we can project ourselves into the future and envision potential outcomes. This intricate dance between past, present, and future moments shapes our consciousness and empowers us to make choices that influence our individual and collective realities. While consciousness has traditionally been seen as a means for survival and understanding the world around us, emerging scientific research suggests that it extends beyond mere utility. It appears that our consciousness has the remarkable ability to impact and create the reality in which we participate. This idea aligns with the growing field of quantum physics. Classical physics, which deals with the behavior of macroscopic objects, has well-established laws that govern our everyday experiences. However, quantum physics unveils a different set of rules that apply to the microscopic world. These quantum laws often defy our classical intuitions and challenge our understanding of reality. One of the most compelling experiments illustrating the influence of consciousness on reality is the double-slit experiment. In this experiment, quantum electrons are shot through a screen with two small vertical slits. In the absence of observation, these particles behave as waves, exhibiting interference patterns on an observing screen. However, when a conscious observer is present, the particles behave as discrete particles, collapsing the wave function and manifesting in specific locations. This phenomenon suggests that human consciousness plays a pivotal role in the behavior and manifestation of quantum particles. Another intriguing experiment conducted by Masaru Emoto explored the relationship between human consciousness and water molecules. Emoto's research demonstrated that water molecules can be influenced by energetic intentions, thoughts, and emotions. Positive words and emotions directed at water caused it to form beautiful and intricate crystalline structures, while negative words and emotions resulted in disorganized and chaotic structures. This experiment suggests that our consciousness has the potential to affect the molecular structure of water, raising profound questions about the influence of our thoughts and intentions on the world around us. Dr. Dean Rodden is a parapsychologist and senior scientist at the Institute of Noetic Sciences. He has conducted extensive research on the relationship between consciousness and reality.
Well, the whole history of science says yes, right? If we were to only rely on our ordinary senses without some form of instruments to amplify what we're capable of seeing, then we would still be living in caves somewhere, or at least we would be like in medieval times. And so, yeah, the reality is far more complex than we can perceive directly.
Through experiments and studies, he has explored phenomena such as telepathy, precognition, and the influence of consciousness on physical systems. Rodden's work suggests that consciousness can have a direct impact on the external world, challenging the traditional understanding of causality. Another prominent scientist who has delved into the connection between consciousness and reality is Dr. Amit Goswami, a theoretical physicist and author. Goswami's research explores the intersection of quantum physics and consciousness. He proposes a framework called consciousness-based physics, which suggests that consciousness is the fundamental aspect of reality, with matter and physical phenomena emerging from it. Goswami argues that our thoughts, intentions, and beliefs shape the world around us, echoing the notion that consciousness actively participates in the creation of reality. Dr. Stuart Hameroff, an anesthesiologist and professor at the University of Arizona, is known for his research on consciousness and the role of microtubules in the brain. Hameroff's theory of orchestrated objective reduction, OR, posits that consciousness arises from quantum processes occurring within these microtubules. According to Hameroff, these quantum processes are responsible for generating our subjective experiences and influencing the nature of reality. The proponents of the concept of consciousness creating reality often emphasize the power of positive thinking, visualization techniques, and the influence of emotions on personal experiences. They argue that by consciously directing our thoughts and intentions toward desired outcomes, we can actively shape the reality we experience. By maintaining a positive and optimistic mindset, individuals may attract positive circumstances and opportunities into their lives. Positive thinking is believed to play a crucial role in the process of consciousness creating reality. When we maintain a positive outlook, we are more likely to perceive opportunities and possibilities in our surroundings. This mindset allows us to approach challenges with a solution-oriented mindset, which can lead to creative problem-solving and the manifestation of desired outcomes. On the other hand, negative thinking often generates self-doubt, limiting beliefs, and a focus on obstacles, which can hinder our ability to shape our reality in a positive way. Visualization techniques are another powerful tool employed by those who embrace the concept of consciousness, creating reality. By vividly imagining the desired outcomes and experiencing the associated positive emotions, individuals can align their thoughts and intentions with their goals. The process of visualization helps create a mental blueprint that guides their actions and attracts the necessary circumstances and resources to manifest their aspirations. Through this practice, they reinforce their belief in the power of their consciousness to shape their reality. Moreover, proponents of consciousness creating reality argue that emotions play a significant role in the manifestation process. Emotions are considered energy in motion, and they emit vibrations that can influence the experiences and events that come into our lives. By consciously cultivating positive emotions, such as joy, gratitude, and love, individuals can amplify the positive vibrations they emit into the unified field of consciousness. This, in turn, can attract experiences and opportunities that resonate with those positive emotions, leading to a more fulfilling and abundant reality. The concept of consciousness creating reality aligns with the belief in interconnectedness and the notion that we are all part of a larger unified field of consciousness. It suggests that our individual consciousness is interconnected with the collective consciousness, and our thoughts and actions have ripple effects that extend beyond ourselves. Just as a pebble creates ripples in a pond, our intentions and actions can create waves of influence that affect the world around us. This interconnectedness implies that when individuals consciously direct their thoughts and intentions toward positive outcomes, they contribute to the collective consciousness in a beneficial way. Their positive energy and intentions become part of the collective energetic field, potentially influencing and inspiring others to do the same. In this way, the concept of consciousness creating reality encourages a shift from individualistic thinking to a more holistic and interconnected perspective, fostering a sense of unity and collaboration. So what do you think?